So let's begin our last session. So we have stopped from the latency and topics from the latency and bandwidth. So we discussed that the bandwidth doesn't depend on the only not depend on the memory. It's already depend on the lines, that the data lines. Okay, even if you have the good enough memory device or memory architecture, you if the with what we call bus data bus can't even not even the data bus, okay, data bus can't even take an good amount of data back to the processor or the other units, peripheral units. You can't say you have the better performance. Okay, so bandwidth doesn't depends on the not only depend on the memory system, it's also depend on the bus width. Okay, the which type of architecture we are using, and that with what amount of data can be parallelly sent. That is the main importance topic. Okay, number of bits that can be parallelly accessed. Okay, that is the main regarding bandwidth. If we can access a higher number of parallel bits regarding, okay, that's fine, then the bandwidth will be high. Okay, if and also speed is also a topic. So it's talking about memory, then speed will be okay. So the last topic we have discussed DDR RAM, that is double data rate RAM. Okay, double data rate SDR RAM, that we are talking double data rate SDRAM. Okay, so what is the SDRAM? So this is a illustration of SDRAM. So nothing big. SDRAM, as we know, synchronized dynamic random access memory. So this is a synchronized DRM, and this is double data rate version. So how is SDRAM, the DDR, that is double data rate? We can now, whenever you purchase a laptop or like any other computer or RAM equipment, we will check one thing: what is the DDR rate. Okay, so whenever I purchase a laptop, I will go for a laptop or something hardware regarding RAM. What I first check is what is the RAM amount and what type of RAM it is. Okay, is this DDR5, DDR4? There is something like this. I will show you, guys. Okay, so let it load. Okay, so then the what is the this is the latest version of SDRAM, common data access is in same way as SDRAM. Okay, as the data access is in the same way as we done in the SDRAM, we will discuss the same way with this is, but there is a small difference. There we will discuss that the data is accessed in the upper edge, okay, or rising edge in the clock. But what happens here, this is a clock, there is a synchronized DRAM, remember that. What happens is here the both edges, that is the rising edge and the lowering edge. Okay, in the both edges we will access the data. Okay, I think that is not loading slow, but maybe there's some network issue. I will show how it goes. So the brush. So this is the clock pulse. You know, the most clock pulse will be ever seen. Okay, so this is the rising edge and this is the lowering edge. Okay, so data will be accessed from here and here. Okay, no problem. Whether that is the advantage, the data is accessed, or data cycle is being initiated on the both edges, both the rising edge and lowering edge. That is the double data rate. Okay, so that is the advantage. And high quality video display, where we need to enhance our memory transfer. So at that particular situations where this SDRAM has been used. So right now we are using DDR everywhere. We are not using any asynchronous. I think we don't use. I'm not personally opinion. I don't made such research. So the next topic we are discussing is structure of larger memory. So as we know, as we discussed, it is only 4 MB or 128 storage. In actual implementation, it is not big enough. Okay, we are using, even all of you using good enough memories. So how it is implemented? Okay, the structure of larger memories, which connected out from large memory, that we are discussing. So first of all, we are discussing a static memory system, how the static memory is implement large memories. Okay, so just go for laptop. Okay, So consider a system of 2 MB like with 32-bit which is not row. So how can we implement it at 2 MB? We can use it as a 512K into 8 architecture. That is, we can use a 512 into 512K into 8 chip. If we have 2 chips or 4 chips, we can easily do this. Okay, each chip has control using so we are using with the help of in the static memory. What we do is we use simple chips and we will integrate this. Okay, we use simple chips and we will integrate the whole chips. Okay, that's we are doing. Okay, so just open any laptop, so I will show you guys. Okay, then we will set an if we set the input equal to 1, so we are not going to so detailed. That is not such more detailed explanation, only simple explanation was given in the textbook, so that's why I preferred it. If I set the input equal to 1, we can either we can input or enable the chip to accept data. So if you want to input the data, we can set the input equal to 1, and in that particular scenario we can input the data or enable chip to accept the data. And in case of reading the data, only the selected, there will be a selecting mechanism. With the we will select the chip using chip select. Okay, there will be a chip select. Chip select is another topic, we will discuss it. This chip select will select a particular chip. That there will be a 4 chip. We will there will be a 4 chip. This is the chip, and this is 0, 1, 2 and 3. So this is the chip serial number. So with the 2-bit binary we can select which we wanted to activate. With this what we do, we select the chip, and only the selected chip places the data on the data line. Okay, there will be a data line going beneath this. Only that selected particular chip will place the data on this. Okay, so we go over specifications. We can memory. Okay, so this is DDR. Okay, this is what DDR. DDR means double data rate. Okay, DDR4. Just if we Google this, we can find DDR is double data rate. So this is a technology which is this is double data rate, synchronous dynamic random access memory. So we got DDR4 SDR RAM. Okay, so this is the thing we are currently using. Okay, so I just put the latest one. I think okay, 1 lakh something. This is the latest one. This is the advanced technology. I think DDR5 is available right now. DDR5. Okay, DDR5 is available. Okay, DDR5 is available, which is much costly. Okay, so just know about like this is a thing called DDR, and whenever you go to buy laptop, just check that what type of DDR it is using, just for an additional information. So okay, so let's we conclude. If we know to select the 2 MB, we need a 32-bit address space. Okay, so we are actually using a 21 address line to select a 32-bit word from this. We are actually a small mistake. So as we discussed, a word of 32-bit each. Okay, we are discussed considering a system of 2 MB, word of 32 bits each. Okay, so at that particular scenario, what happens is we need a 21-bit address line. 21 address line, since we have to access 22M data, so we need to address a 21 address line to select a 32-bit. So among the 21, there will be 2-bit decode which chip is will use it. So here I am using 4 chips, 512 into 4, so 512 into 8. So 512 into 8 architecture. So for that there will be required 4 chips for making a 2 MP. So that's why I am using 4 chips. For selecting, we need 2 bits. Okay, right, 000101, sorry, 1011. So that's the concept here. Last thing we have to discuss is okay, that's all. int 2-bit decode which and remaining will be specified remaining will specify the address. Okay, that's all. For read and write there will be a common control, that's the thing. So in the case of dynamic memory systems, there will be memory modules. Modern computers use there will be memory module, that is not it is implemented by using memory module. Modern computers use very large scale memories, like as we know, okay, very large scale memories. That means if we made our primary memory, that's our RAM, much larger, what happens is the main large mother, that's the as we know, we will put the memory chips on the motherboard. So data power memory chips or our RAM device so big enough. So what happens is motherboard will be so big. Okay, so what we do is maximum we will reduce the size so that the motherboard will be maximum compact. So larger primary memory means larger area of memory required, and to increase our memory, what we have to do is we were depending on the secondary memory. That's the okay. So what here just I didn't made a prepared note for this topic, so that's why I am using this one. So like this. So as we discussed, as large memory leads to better performance because of however in a large, as we know, large memory can improve the performance. However, if we larger memory to build by placing the that means from the motherboard to where will that means this is the region where the space that is discussed. If we are increasing our what we call as space, it will occupy an unacceptable large amount of space in the motherboard or larger in the space of board. So we can that will occur to provide for in future. As we know, in the future we are making our devices more compact. So other scenario we can make it large. So that's why we are using memory modules. There is two things, SIM and DIM. SIM means single line memory module, and DIMS means double in-line memory modules. Okay, so that's it. And these memory modules are assembled by several memory chips. That means both the SIM and DIMs are made by assembling of several simple units on a separate board. Okay, and that are plugged in vertically. Okay, so I will see. Okay, don't photograph now. So that's how we implement this, and we also do like an expansion card. Okay, I will show that. Expansion card. So I think this will be a okay, using like these cards. Okay, we will expand our memory using chips like memory expansion cards like that. Okay, so this is what dynamic memory allocation. I will take the dynamic memory allocation region more explained in the Google Meet. I think it will be better. Even I am so much. I think I left some places untouched. So this is single and double element we are talking. So nothing much. Okay, so this is the okay. Okay, so I think this is I think okay. I think you have seen device like this. This is expansion card. We can also expand our device RAM with this type of chip. Okay, this is for communication. It's not actually RAM type. There will be an expansion memory card. Okay, for this regarding the memory, this for network. Okay, actually almost topic has been completed. So we will discuss it in the Google Meet. Thank you.